Now, as you know, the retina is the light-sensitive area at the back of the eye. It contains rods and cones, the light-sensitive cells, and these convert the light impulse into an electrical impulse, which goes to the optic nerve and onto the occipital lobe of the brain, where it's interpreted as vision. So here we have the retina at the back of the eye. And as we know in diabetes, part of the problem is that the capillaries get a thicker basement membrane. So there's a thickening of the basement membrane. And as well as being thicker, as we've said, the basement membrane is more permeable. So plasma fluid can leak out into the retina. So the capillaries in the retina can become leaky, and we can get exudates accumulating in areas of the retina, and this can damage the very delicate light-sensitive cells as a result of the exudate. But as the basement membranes become thicker, the thick basement membrane kind of starts to close off the capillaries. And as well as that, it loses the pulsatile ability, which evens out the blood flow through to the tissue. So what this means is you can start to get ischemic changes in the areas of the retina that this microscopic blood vessel would normally supply. And as well as that, you get proliferation of the endothelial cells inside the capillary. So you get thickening of the basement membrane pushing in. You lose the ability to smooth out the blood flow, and also the lumen of the capillary gets clogged up by a proliferation of vascular endothelial cells. And this means that an area of the retina now is going to be ischemic and therefore hypoxic. So that's bad for the retina as well. So we've got areas of exudate, and now we've got an area of hypoxic ischemia. So that's bad. But the hypoxia stimulates the development of new blood vessels as well. So the hypoxia, because it's in a hypoxic area, that stimulates new blood vessels to grow into the retina. And you might think that that's good, and in fact, in a sense it is good, because blood can go in the new blood vessels to this area of the retina and carry oxygen and correct the hypoxia. So that sounds good, that the retina's kind of healed itself. But the problem is, these new blood vessels develop quickly and are of low quality. The walls of these new blood vessels are quite friable and they burst. So you can get bursting of these walls leading to areas of blood leaking out into the retina, and of course this gives us a retinal hemorrhage. So we get retinal hemorrhage, and the presence of the blood lying over the retina will kill the retinal cells in that area. So we've got exudates accumulating in the retina, we've got hypoxia, we've got new blood vessels which are bursting, causing retinal hemorrhages. So there's quite a few insults to the retina here. So what are we going to do about this? Well, again, we need to keep the blood sugar down near physiological levels. Many trials have shown this, that if we can keep the blood sugar levels down, the prognosis in terms of eyesight and renal function is improved. So good glycemic control, absolutely vital. Good blood pressure control, also important for the retina, just as it's important for the kidneys. So we've looked at the microvascular disease causing diabetic, nephropathy affecting the kidneys, retinopathy affecting the eyes, and the next one we want to look at is neuropathy, as it can affect the nervous system, affecting the neurons.